Data hierarchy. We can make it in order from smallest to biggest, right? This is the order, from smallest to biggest, right? Between 1 or 0, right? By like 8 bits, right? 8 bits, right? Field mean one attribute. It's like name, age, right? What about record? Records mean all fields about one person, right? Files, collection of records, and database, collection of files, right? Simply remember like that, okay? What is the database structure? The database structure is rules and plans for how database organized and used, right? Sorry, not database, how data is organized or used, right? Data types. What kind of data can go in each place? Like numbers, text, dates, right? Relationships. How pieces of data connect to each other, right? Like student and course, right? Constraints, right? Rules that the data must follow, like a student ID must be unique, right? Plus, the database allows you to retrieve data. It means ask questions like which students are in course, right? And update data, change or add new informations like adding a new student, right? So basically, structure means what data is stored, how it's connected, rules for it, and how you can use it, right? The next topic is data model, right? We can categorize it into two types, which are high level and low level, right? High level is conceptual, right? Low level is physical. Let's discuss high level, right? What about high level? Easy for humans to understand, right? And shows the big picture, not detail, right? Examples. Think. If I say a school has students and teachers, right? That's high level, okay? It shows a big picture but not detailed, right? What about low level? Low level means close to how database actually stores data, right? Consists of full of technical details, right? And harder for humans but easier to the computer, right? Example, how data is stored in blocks, records, pointers, memory. That's low level, okay? These models show the structure of data in an easy, human-friendly way, right? Examples, ER model, EER model, object model, right? We can see attributes, entities, relationships, and entities, right? No storage details, right? Now, these models show how the computer stores data physically, right? Record-based modules, how files look, how records are stored, how blocks are arranged. This is closer to the hardware, right? What are the examples of data models? Hierarchical, network, relational, etc., right? These are record-based models, right? So, they are considered low-level and representational, right? Why? Because they described how data is stored, how records are linked, how the DBMS will organize data internally, right? For example, hierarchical, network, relational, right? That's all the low-level data models, right? Hierarchical uses tree structure, right? Network uses pointers and links. Relational uses tables, keys, tuples, right? These are closer to how the DBMS actually works, so they are not high level, right? What is the schema? It is a blueprint of the database. Otherwise, you can say description of the database, right? You can see schemas tab, okay? It tells what table exists, right? Tables. What attributes and columns exist. Attributes and columns, right? What relationships exist? I don't have any example right there. What constraint exist, right? And a schema does not change often, right? It's like the structure of a house. Once built, the plan stays same, right? Example, table CN, right? You can see columns IDCN, CT, likewise, right? This table design equals to schema, right? Instance, right? What is the instance? An instance equal to the actual data stored at a moment, right? If schema is the table design, instance is the rows inside the table right now, right? Row. Instances change all the time, right? Every insert, delete, update can change the instance, right? If we add the data, instance can change, right? These rows equal to instance, right? Rows are equal to instance, like this. We can represent it like this, right? A displayed schema is the schema diagram, right? What is the database state? It is a total set of all instances in whole database at a given time, right? Set of instance mean all of these, right? Okay. It's like a snapshot of the entire database right now, right? When data changes, state changes, right? Simply remember, data state equal to collection of all instance, right? We can categorize states into three types, right? First one is empty state, right? In this case, database has no data yet, right? No data, right? All tables exist, but there are 0 rows inside them, right? See? No rows, right? Think of like just build a house but no furniture yet, right? It means empty house, right? Initial state, right? This is the first set of data loaded into the database after creation, right? Happens right after system installation, right? Often contains setup or default data, right? Not empty, but minimal, right? Example, a university database might have list of departments, admin user, basic cost list, right? It's the starting point of the system, right? Third one is current state, right? This is the state right now, at this time, right? After many inserts, deletes, updates over time, right? It changes constantly, right? Whatever data is in the DB right now equal to current state, right? Every modifications updates the current state, right? Every modification updates the current state, right? It's like a live photo of the database at this second, right? Let's move on to classification of database, right? Based on data models, right? First one is hierarchical database. We can call it as tree model, right? You can call it as tree model, right? Okay. Now, in this model, organizes data in a tree structure, right? Parent, child, right? One parent can have many children, right? But child has only one parent, right? Child can't have no parents, right? Example, IBM, IMS. Think about family tree, right? Second one is network DBMS, or we can call it as graph model, right? It extends hierarchical model, right? A child can have multiple parents, right? Like this, 1, 2, right? One child can have multiple parents, right? Supports more complex relationships, right? Example, integrated data store, right? Think about web of connections, right? The third one is relational database, right? Also, we can call it a table model, right? This is the most common today, right? Data is stored in tables, see, which have columns and rows, right? Columns and rows, right? This uses foreign and primary keys, right? Think of an Excel sheet, right? The fourth one is object-oriented database, right? Also, we can call it a object model, sorry. Object model, right? And it stores data as objects, like in OOP languages, right? It contains both data and methods, okay? Examples: object DB, DB4O, right? Think of the Java objects stored directly in the DB, right? Fifth one is client-server DBMS, right? It is a database system where the work is divided between client and server, right? They communicate over a network, right? Client equal to user side, or we can say front end, right? Server is a database site, we can say backend, right? How it works: client sends a request, right? Like, give me all students. Client sends a request, right? Server processes the query, right? And server sends the result back to the client. Send request, send result, right? Okay, simply remember, client equal asks, server equals answers, right? Why we use client-server DBMS? Because it separates responsibilities, right? What are the responsibilities of client? UI, sending queries, showing results, right? What are the responsibilities of server? Storing data, processing queries, ensuring security, managing transactions, right? We have two types of client-server DBMS, right? What are they? 2-tier and 3-tier types, right? Let's explain about first one, 2-tier architecture, right? 2-tier architecture. Clients talks directly to server. No intermediate things, right? Sorry, not you can see without any intermediary they can communicate, right? Client sends SQL directly, right? Examples: Java app to MySQL, right? This is easy but less secure for large systems, right? The 3-tier architecture. It has client, application server and database server. Okay. Clients does not talk to DB directly, right? See, it wants an intermediary, right? Okay, middle layer handles business logic, right? Example: web apps. You can get it as browser, server and DB, right? This is more secure, scalable and modular, right? Remember, client-server DBMS is a DBMS architecture model, right? But we have another model, object relational DBMS, right? This is the mix of relational and object-oriented models, right? It allows complex data types like images, videos, and objects, right? Example, Oracle. Think of tables and objects together, right? Also, we can classify DBMS according to the number of users, right? We have two types, single users and multiple users, right? Check first one, single users, right? Only one user can access the DB at a time, right? Usually used on our personal computers. It is light and simple, right? Examples, Microsoft Access, SQLite, likewise, right? Think of just you using your own database, right? Second one is multiple users, right? Many users can access the database at the same time, right? Needs stronger memory, security, concurrency control, right? This is used in companies, banks, universities, right? Example, MySQL, Oracle, etc. Think many users logging into the same system, right? We can classify DBMS according to the number of sites where the database is stored, right? First one is centralized DBMS. We can call it as one site, okay? All the data is stored in one place. It means one server or one location, right? It is easy to manage, fast communication. If the server fails, whole DB fails, right? Example, a small shop system with one computer storing all the data, right? Think everything is in one cupboard, right? The second one is distributed DBMS. We can call it as multiple tasks, right? Database is stored in more than one location, but all locations work together as one database, right? This is faster access for remote users, more reliable mean if one site fails, others work, right? And better performance, more complex to manage. Examples, a bank with branches in many cities, right? Each branch has its own data, but all branches share a common database system, right? Think same textbook, but multiple copies in different classrooms, right?